Hello, welcome back. Today we're going to be talking about finding the areas of trapezoids, rhombuses, and kites. And by the end of this video, you should be able to find the area of a trapezoid, a rhombus, and a kite. Here are the area formulas you have to know for this unit. It'd be a good idea to go ahead and write these down so that you can use them while you're working on your assignment. Now, the area of a rhombus is 1/2 of the diagonals being multiplied together. Diagonal 1 times diagonal 2. The area of a trapezoid is 1/2, add the bases, then multiply by the height. And I've written down here again what the D stand for. They stand for rhombuses or kites diagonals. And the B1 and B2 are the trapezoid's bases. And the H is the trapezoid's height. So we're going to take a look at a couple pictures to remind us again of what the bases and heights are. Here's a trapezoid. And you've got the bases on the top and the bottom. They're not always top and bottom. And you've got the height, and the way you know that these are the bases is they're running the same direction or they're parallel. These other two sides right here don't go the same direction, so that means they cannot be the base. I could just as easily turn that figure around, and you'll notice that the bases are still parallel to each other, even though they're not necessarily top and bottom. And that might happen as you're working through a problem, as they might make the bases face the other direction. Now the rhombuses, the diagonals, are the things that go from corner to corner. Same way with a kite. Diagonals go from corner to corner. And your textbook might, or your problems might, show you the length of the diagonals like this. You see how it goes D1, D2 right here? That's just showing you that from corner to corner it is this distance. And from this corner to this corner it's this distance right here. And they might do the same thing with a kite. So a rhombus diagonals D1, D2, and a kite diagonals D1, D2. I'd like to take a note that these pictures were taken from McDougall-Littell book from page 730 and 731. Now, how to find the area of a figure, I've went ahead and written down some steps to remind us. First thing we need always to do is decide which shape we're given. Then we need to decide what the correct formula is and write it down. And then we can substitute in the values we know and solve for the area. Now what I want you to do is I want you to go ahead and find the areas below, and I'll write down the values that you need to know in order to find those areas here in a second. So for this first shape, let's say that the height, which I'm going to list right like this, is 5, and the first base is, let's say that's 4, and this one is 8. See if you can find the area of this particular shape right here. Now, this shape, let's say that the height, now sometimes they're going to show you the height like this, and that's okay. Just note that it's not really part of the figure. They're just showing you the height off to the side. Let's say the height of this one is 7, and this base is 10, and this base is 3. Go ahead and again find the area of these two figures using your formulas. The first one, we notice that it is a trapezoid, so the area is going to be equal to 1/2 base 1 plus base 2 times the height. So we're going to go half of base 1, our first base is 4, plus our second base is 8, times the height, which is 5. So we get 1/2 of 4 plus 8 is 12 times 5, and you're always welcome to use your calculator for these. 1/2 of 12 is 6, times 5 is 30. So the area of our first shape should have been 30. Now looking at our second shape, we're going to use the exact same formula, and we're going to go the area is going to be equal to 1/2 base 1, 10, plus base 2, 3, times the height, which is 7. So we get 1/2 of 10 plus 3 is 13 times 7. Half of 13 is 6.5 times 7. And again, you can use your calculator. You're going to get 45.5. I think I just got to do it in my head. Go ahead and use the calculator to check that for yourself. But again, you find out what shape you have, you write down the formula, then you substitute in the values that you know. Go ahead and see if you can find the areas of these two shapes. Now these two are going to require a little bit more thought than perhaps the previous ones did. and you're probably going to need a calculator to work these out. But go ahead and pause the video, see if you can find the areas of these two shapes, and press play when you're ready to see the answer. Went ahead and got you started. For the first one, area is equal to 1/2 diagonal 1 times diagonal 2, since it is a kite. Now 1/2 times 16 times 7.5, 16 being one of our diagonals and 7.5 being the other, should give us the area of this shape, and I'll type that in the calculator here in a second. Now for the other one, the diagonals weren't really given to us. We were only given half the diagonals, but since it was a rhombus, you were supposed to note that the diagonals should have been bisected by each other. So if this distance is 2.7, the distance in blue that I've written, that means the distance the other direction should also be 2.7. And what that 1.4 was pointing to was this diagonal right here. If this is 1.4, then this also should have been 1.4. So we had to add up the two halves to find the total length of this diagonal. So this diagonal is 1.4 plus 1.4. You could do that in your calculator. Should be 2.8. And the length of this diagonal, the one that goes from left to right, is 2.7 plus 2.7, which should be 5.4. So our diagonals then are 2.8 and 5.4. So times 2.8 times 5.4. And again, I'm going to use a calculator to find both of those. Let's find the area of the first one. You can type in 1/2 or just 0.5. I think 0.5 is a little easier for me, but if you want to, you can do 1 divided by 2 times 16 times 7.5. And that gives you the area of that first shape, which happened to be a kite, which is 60. So our first shape has an area of 60. Now the area of our second shape was 1/2 times 2.8 times 5.4. And we find out that that is 7.56. So there you go, you found the area of a kite and the area of a rhombus. Now we're about to solve from some missing information, and we've done this in the past, so I've just written down steps if you'd like to have them. And they tell us that when we're trying to solve for x, given an area and some other information, we need to find out what figure we're given. Always start with trying to find out what figure you're given. Then, if you're given an area, write down the formula for the area. And we're going to substitute in the numbers for the letters that we know in the formula. And you may have to think some to find some of the letters, and then we're going to solve for the missing letter. So we're going to use some information to find the value of x in this diagram right here. Now, what I don't like about these diagrams sometimes is they don't label very clearly where the x is or where the dimensions are. So let me show you. The 12 clearly is the distance going from here all the way down to here. And the 5s are this distance and this distance. That's what the 5s are pointing to. The x, we're not exactly told what the x is, but since it's right up against this length right here, I'm going to outline that in green. We're going to assume that the x is pointing to that distance right there. So what I'm going to do again is I'm going to figure out what shape I'm given first. And looking at it, looks like I'm given a kite. So the area of a kite is going to be equal to 1/2 diagonal 1 times diagonal 2. So the area, which I happen to know, is 80, so I put 80 in for the area. 1/2 diagonal 1. Now I do know one of the diagonals. I'm going to outline that in blue. Notice this is 5 and 5, so the whole diagonal length is 10. Times diagonal 2. Now, we don't know diagonal 2. It's green and the red distance, so we have to add those two together in order to find diagonal 2. And this is where the problem gets a little bit more tricky, because in this case, now it doesn't always work out this way. Just for this problem, we find out we have to add the 12 and the x to find diagonal 2. So I'm going to put that in parentheses because they're together. So I'm going to go 12 plus x. So Let's see if we can solve it. 80 equals 1/2 of 10. Well, half of 10 is 5. Times 12 plus x. Now, we haven't solved a problem like this in a while, but in order to get x by itself, you notice it's trapped in the parentheses. We need to distribute the 5 first. So we get 80 equals 5 times 12 is 60 plus 5x. And now we can solve our equation using the reverse order of operations. So we're always going to subtract or add first. So we subtract 60 from both sides, giving us 20 equals 5x. And then we can divide both sides by 5, giving us in the end x is equal to 4. Now, again, all the problems don't work out like this one did. It just so happens this one worked out this way. But the steps are always the same. Find out what shape you're given, write down the formula, substitute in what you know, and then try to solve the equation that you're given. Now, what I'd like you to do is to try on your own to use the information you're given in this problem to solve for the value of x, or to find x. Go ahead and try that on your own, pausing the video, and press play when you're ready to see the answer. Now, if we look at this figure, we'll notice that this is a trapezoid because we have 2 bases and 2 other sides that aren't going the same direction. And we notice the 2 bases are also parallel, so it's got to be a trapezoid. So the area of a trapezoid is equal to 1/2. By the way, it's always good to identify that we're looking at a trapezoid. And maybe even write that down. So it's 1/2 base 1 plus base 2 times the height. Now, the area we're actually given, so we can substitute 5.5 in for our area. 1/2 base 1, 2.3, plus base 2, 3.2, times the height, which is x. So 5.5 equals 1/2. We can find out what 2.3 plus 3.2 is. That should be 5.5 times x. Now, there's 2 ways you can solve this right now, but you can either divide both sides by 1/2 and then divide both sides by 5.5, or we can just multiply 1/2 times 5.5. And I'm going to use my calculator to do that real quick. I'm going to go 1/2 times 5.5, and I'll notice I get 2.75. So move that out of the way. So we get 5.5 equals 2.75x. Now, we can still get x by itself by dividing both sides by 2.75. And we'll go back to our calculator. 5.5 divided by 2.75 equals 2. So we find out in the end that our x value is 2. Now, you can always check your answer by substituting the x back into the equation, multiplying it all out, and seeing if the left side equals the right side. But anyways, this is our answer, and that's it.